Good morning, dear students. I, Rakesh Singh, welcome you all on online teaching class in a Holy Cross High School. I hope you all are safe and healthy and doing your studies regularly. Today, I will begin with chapter number 3, that is current electricity. Children, we all know that electricity is a part and parcel of our life. We depend on it for almost everything in our daily life. For example, in our house, there are many devices, many appliances like fridge, electric oven, mixer, fans, washing machine, vacuum cleaner. All this cannot run without electricity. Electricity saves not only time but also labor. In order to avoid the inconvenience faced due to the failure of power supply in hospitals, banks, offices, private institutions, there is alternative arrangements with the help of generators. Means, children, you will see in the banks, in the hospitals, there is a big machines. Even in factories, there are big machines. Suppose the power supply is stopped, then how they provide electricity? If suppose operation is going on in the hospital, then how they will supply electricity? So they have alternative sources, that is generator. So generator produce electricity. Children, not only the human beings but also animals also use electricity. Example, there are fishes such as eels, right, uses electricity. Why they use this electricity? To catch their prey and for self-defense. Even children, the lightning that strikes the earth during the rainy season, you have seen that lightning which strikes the earth is an excellent example of natural flow of electricity. So children, I will explain you first what is the meaning of electricity. How you will define electricity? Children, electricity is nothing but flow of charges, flow of electrical power. We have two types of electricity. It is not mentioned in your textbook, children, but we should know that there are two types of electricity. First one is called as a static electricity. Second one is a dynamic electricity. Children, this static electricity you have done in 8th standard. There are 2-3 examples if I will say. That is, if you will rub glass rod on a silk cloth, so what happens on the glass rod? The charge develops. Similarly, if you will rub your ruler on your hair, then what happens to the ruler? It develops the charges. That is a temporary electricity. It is called as a static electricity. Second one is a dynamic electricity. In this chapter, I am going to deal with the dynamic electricity. Here, you are going to learn many things of electricity about circuit. What are the components are used in the circuit? There are rules, there are laws which you are going to learn in this chapter. Static electricity, again I'm telling you, is the temporary electricity. And as I said, if you will rub glass rod on a silk cloth, so glass rod develops a positive charge and silk cloth gets the negative charge. Examples of dynamic electricity is electricity that is connected using cable to turn on the televisions, fans is called dynamic electricity. So children, how you will define dynamic electricity? Dynamic electricity is the flow of electric charge through a conductor. Now children, I have attached a video of electric current. Please watch it. You will understand the concept better.
Do you recognize the person you see on your screen? Yes, he is the great Thomas Edison. Do you know what he is known for? In 1879, he invented the first practical, long lasting electric light bulb. And since then, our homes are bright even after sunset. You must be aware of the fact that lights in our homes work on electricity. However, they're not the only ones that use electricity. Our televisions, air conditioners, water heaters, fans, and so on also need electricity to function. Laser light or even small flashlights also work on electricity. Imagine a life without electricity in the world today. The discovery of electricity has helped to start a new revolution in the history of humankind. But let's just keep aside all the rhetoric talks and try to understand the real thing. I haven't really told you what the term electricity means. Well, there are basically two forms of electricity. One is static electricity and the other is dynamic electricity. For now, we are only interested in dynamic electricity. From the name itself, we can say that it implies moving electricity, or more precisely, moving electric charges. Now, the next question you have will be, what are electric charges? The concept of electric charges is very important in physics and it cannot be explained in a video or two. But I will still try to give you a short and to the point explanation of this concept. So let's begin. There are two types of electric charges: positive, denoted by the plus sign, and negative, denoted by the minus sign. Think of magnets for a moment. We know that two like poles, that is, two north or two south poles of magnets, repel each other, and unlike poles attract each other. Similarly, like charges, that is, two positive or two negative ones, repel each other, and unlike charges, that is, a positive and a negative one, attract each other. But what exactly is charged? Or, in other words, who actually carries these charges? Well, these charges are carried by tiny particles with incredibly small mass. They are called subatomic particles. The positive charges are carried by particles called protons, while negative ones are carried by particles called electrons. There are billions and trillions of protons and electrons present in any object around us. In some objects like metals, electrons can move randomly, while in non-metals, their position is kind of fixed and hence they cannot move freely. Now, any appliance in our house, for example a tube light, works because the negatively charged electrons are moving in the wire in one direction. This unidirectional motion of electrons in a wire is also called electric current. These wires are made of metal, usually copper or aluminium, and you can understand why. But why are the charges in a wire moving in one direction? Or what makes the charges move in the wire? The charges move in one direction in the wires because of the energy supplied to them by the transformers. So the transformer supplies energy, the charges move in a wire, which in turn makes our appliances work. A flashlight also works the same way, but here the energy is supplied by the two electric batteries. So to sum it all up, dynamic electricity is flow of electric charges through conductors like, say, a copper wire. Generally, when we talk about electricity or electric current, we mean dynamic electricity. Hence, we simply say that electricity is nothing but the flow of electric charges through a conductor. In the next video, we will learn how to light up a small torch bulb using a single electric cell. So see you there.
So children, I hope all of you have understood what is the meaning of electric charge. Your second topic in the chapter is what is potential and potential difference. Now, I will give you example of potential and potential difference. Like in your house, you have water tank. When you will open the tap, what will happen? The water comes out. Why this happen, children? Because water tank is kept at certain height. So here there is a water level. Water always flows from higher level to the lower level. So this level is called as a potential. Similarly, in electricity, the flow of electric charge between 2 points. The flow of electric charge between 2 points depend upon the kind of electric label. Electric label means what? Like you have two terminals. One is called as a positive and negative. So the flow of electric charge depends upon the two electric label. Okay, and this is called as a electric potentials. See, again I'm telling you children, second topic is very important, that is what is potential and potential difference. As I gave you example that in your house there is a water tank. When you will open the tap, then what happens? Water comes out. Why this happened? Because the water tank is kept at certain height. Okay, water flows always from higher level to the lower level. So this is called as a, this label is called as a potential. Similarly, in electricity you have flow of electric charge. The charge flow from higher level to the lower level. Between, if the two charges are connected between, if the two charges are connected by the conductor, then they flow from higher level to the lower level, and this is called as a electric potentials. As you can see in this page, what is given here, a positive charge flows from a point of higher potential to a point of lower potentials. We have seen earlier that electricity flows due to conduction of negative charge electrons. Electrons flow from the point of lower potential to a point of higher potentials. I will give you a very good example. During the rainy season, you have seen the lightning in the sky. Okay, children. So what happens here? These clouds have a steam, or you can say they have a lots of water. When the clouds rub with each other, when the clouds rub with each other, and due to this uh, rubbing, the charge develops, which is called as a negative charge. Okay, and this negative charge in the form of lightning comes from cloud to the earth, which is have a zero potential, means lower level. So the lightning strikes the flow of electron from point of lower, that is negative potential, on the clouds to the point of higher, that is zero potential on the earth. So that when clouds rub with each other, because of that rubbing, negative charge develop. Okay, and that comes on the earth in the form of lightning. Same thing when you will connect two terminals with the conductor like a copper wire, the charges flows from uh, higher level to the lower level. Here you can see in the picture there are two label. One is a positive charge conductor and second one is a negative charge conductor. Positive charge conductor is denoted by plus, which is a high electric potential, and the negative charge conductor is denoted by negative sign. It is a low electric potential, and these two charges are connected, or electric potentials are connected by a conductor, you can say here as a copper wire. Now, because there is a high electric potential and low electric potential, so high and low, due to this, what you will get? Difference you will get. And this difference is called as a potential difference. There are two charges. One is high and second is low. And these two are connected by a conducting wire. Okay, and it shows a difference, so it is called as a potential difference. So first I said about what is potential, and then now it is what is potential difference. See what is given in the textbook: the difference between the values of potentials at point A and B is called the potential difference. Means the difference between high electric potential and low electric potential. Suppose that high electric potential is having 100 volt and low electric potential is having 70 volt. So the difference between these two is 30 volt. So potential difference is the difference between the two electrical po- potentials. Also children, you can see that conductor A is at a higher potential, as I said this one, and the conductor B is at a lower potentials. When these two are connected by a conductor, that is copper wire. Okay, so what will happen? Potential difference is developed between these two ends, and because of that reason, electrons will flow from B to A through the wire. So children, always you keep in mind that the electrons are negatively charged and they always flow from B, lower electric potential, to the higher electric potential, that is from point B to point A. The electron will flow from B to A through the wire. This flow will continue until the two conductors A and B have the same potential. So the flow of electron will continue, children, till both the potentials becomes equal, becomes same. A and B have the same potentials. That is, until the potential difference becomes zero. If A and B becomes equal, then there is no difference. If there is no difference, means potential difference is zero. Okay, so therefore the flow of electron will stop. Only then the flow of electron will stop, and work has to be done against the electric field to take positive charge from a point of lower potential to a point of higher potential. So overall, I will say here that electron will flow from negative terminal to the positive terminal, and the current will flow from positive terminal to the negative terminal. So children, this keep in mind that electron flows from negative terminal to the positive terminal, and the current will flow from positive terminal to the negative terminal. Now related to this, I have prepared one video. Please see this video and try to understand this.
Imagine you have two beakers filled with equal amounts of water, and they are both connected to each other by a pipe at the bottom. If you observe the two beakers for a few seconds, do you think the water will flow from one beaker to another? No. You will see that the water in both beakers is as is, and there is no flow from any beaker to the other. Now let me give you a task. Without changing the amount of water in any of the beakers, can you make water flow from beaker 2 to beaker 1? Understand my question again. You need to make water flow from beaker 2 to beaker 1. But you're not allowed to change the amount of water in any of the beakers. So you can't add or remove the water from any beaker. How will you do it? It's easy. One of the things you could do is raise the height at which the second beaker is kept. Once it's raised at a height, the water will flow from beaker 2 to beaker 1. What exactly happened here? What was the factor that made water flow? In simple terms, the factor was height. Yes, you can talk about gravity or pressure difference. But in layman terms, it is the height difference that causes the water to flow from the second beaker to the first. In an exactly similar way, for electricity to flow, there has to be some factor. We'll come to that factor soon, don't worry. So if we just have a copper wire, do you think electricity will flow through it? Clearly not, because there's nothing that's triggering it. There's no factor triggering it. So what is the factor that triggers the flow of electricity? It's called the potential difference. Now, I can't define this term in one line, but that wouldn't help you understand the concept well. So let's dive a bit deeper into it. We see the word potential here. Have you heard this term before? Of course, we've heard of potential energy. It is the stored energy when an object is at rest. When you're holding a ball in your hand, it has potential energy. When you drop it, the potential energy is getting converted to kinetic energy when it drops to the ground. Kinetic energy is the energy an object has when it's in motion. Similarly, there is a concept of electric potential energy. The electric potential energy of any charge describes how much stored energy it has. Just like the ball in your hand has high potential energy, a negative charge close to another negative charge has high potential energy. If left free, the charge will be repelled by the negative charge and will move towards the positive charge, just like the ball will fall towards the earth. What's potential difference then? It's just a difference of electric pressure between 2 points. And this difference may arise because of a battery consisting of cells. Potential difference is also referred to as voltage. If we have to understand the technical definition, we would say that it is the work done to move a unit charge from one point to another. The potential difference V between any 2 points in an electric circuit will be the work done over the charge Q. We know that the work is measured in joules and charge is measured in coulombs. What's the SI unit of potential difference then? It's volt, named after Alessandro Volta, an Italian physicist. So how would we define volt in a current carrying conductor? It is the potential difference between any 2 points when 1 joule of work is done to move a charge of 1 coulomb from one point to another. The potential difference is measured by an instrument called voltmeter. It's measured in parallel across the points between which the potential difference is to be measured. In the next lesson, we will solve an example related to potential difference.
Hope you have understood this much, children. I will continue further in my next video. Thank you, students. Be safe. God bless you all.